The objective of this video is to review our course learning outcomes and discuss the course plan for the remainder of the semester. So we've gone through this a few times, but it's nice to keep this in your mind as a roadmap for what this course is trying to help you accomplish. By the end of this course, you should be able to analyze, derive operating principles, and sketch transient voltage and current waveforms for common power electronic circuits. This includes DC to DC converters, DC to AC converters, and AC to DC converters. For this learning outcome, we've so far gone in depth on DC to DC converters. We've also discussed AC to DC converters, or rectifiers, and we have briefly commented on DC to AC converters. We're going to come back to DC to AC converters, or inverters, later in the course. The second learning outcome is that by the end of this course, you should be able to dimension and select key components in power electronic circuits in order to meet a design specification. This has been a reoccurring theme throughout the semester and will continue to be for the remainder of the semester. Finally, the last learning outcome of this course is that by the time you finish this course, you should be able to analyze the performance and conduct basic design steps for closed-loop regulation of power electronic circuits. This is the unit that we have just finished. We've now concluded our controls unit, and we've gone in depth on analyzing the performance and conducting basic design steps for closed-loop regulation. We've done this through Bode plots, through small signal analysis, and through the op-amp realization of our regulators. What we're going to do now is we're going to enter a unit on transformer and inductor design. But before we can do that, we need to review basic magnetic circuit concepts and use these concepts to derive the equivalent circuit for a transformer. Then we'll launch into the design process for inductors and transformers. So today's lecture, and the two videos that follow this, should be somewhat of a review of magnetic circuit concepts or magnetic field concepts, but there'll be a twist on these because we're viewing them through the lens of power electronics and power engineering. So whilst I expect these concepts to be familiar, please pay attention because you'll find that we have a different way of thinking about things when it comes to transformers and inductors. This unit will last for 2 days, and after that we'll be launching into considering DC to DC and DC to AC converters that rely on transformers. These will be using high-frequency transformers that will leverage the designs that we come up with in the next 2 videos. And finally, the last few weeks of the course, or the last few lectures of the course, are going to be focused on DC to AC converters, or inverters. So this gives you a roadmap of where we are in the semester. We've finished our 2 major units, which were DC to DC converters and the regulation for power electronic circuits. And now we're tying up details with transformer design, inductor design, and inverter operation, all of which build upon building blocks that we've discussed so far in the course.